Hey everyone, so this is your second video homework that you're going to have to go through and watch, and you're going to be following along with page 19 and 20 in your packet. So page 19 and 20. So on Monday and Tuesday, you guys were working on solving quadratics that have a B term using the quadratic formula, and the lesson that you guys are going to do on Wednesday is going to have you apply that to some real world scenarios. So this first page on page 19, there's no work to be done out. It's just showing you the difference between the falling object formula and what we're going to learn about, which is called the velocity formula. So falling, you're literally just falling over. You're not going up and then down. Whereas in a velocity problem, because you have that extra force behind you, you're going to be going up and then back down to create more of the parabolic shape. So you're going to end up having a B term, and in the real world, that B term is going to stand for your velocity term, which is like your speed. So there's a new formula here next to the snowboarding picture that looks similar to the falling formula, except it has this middle, it's pronounced V naught T. That little sub-zero is always pronounced not, like when you tie your shoe in a knot. That's just how you say it. So that has to do with the velocity. Or the speed behind your object that's going up and then down again. So h of t is still the height as it's going up and then down, and it's determined by the question. V naught will be your velocity. T is still time, and it will be in seconds. And h naught is, again, the initial height there at the end. So new formula for problems that have a velocity in it versus a falling problem does not have a velocity. So nothing to write down here, just wanted to show you visually the difference between the two and what the new formula is going to look like. If you now go to page 20, we're going to take some notes. So objects with velocity in the real world. So just restating again, we previously learned the falling object formula for an object that falls or is dropped, and now we're going to write the formula for an object that is launched or thrown with velocity. And they'll have that B term. So drop formula, velocity formula. We're going to redefine our variables here. So h of t is going to be just the height. Okay, look at what the question is asking. We might have to figure out how long it takes for it to reach a height of 10 feet or how long until something reaches the ground. We'll figure that out by the question of the real world situation. T is your time in seconds. H naught is the initial height, and V naught is the initial velocity. So the initial vertical velocity can either be positive, negative, or zero. So I'm just keep reading along with me on this handout right here. So if the object is launched upwards, then its velocity is going to be positive. So if it's launched in an upward direction, like if this picture down here, kicking a football, okay, we have a positive velocity when you go in an upward direction, like kicking a football, kicking a field goal. Whereas if an object is launched downwards, and if you look at the middle picture on the bottom, like spiking a volleyball, so when you're spiking the volleyball in a downward direction with some velocity behind it, then the velocity is going to be negative. And then if a object is launched horizontally, okay, so if you're throwing a baseball without that arc, so like a pitcher, then that baseball could have zero velocity. If you're throwing a baseball, like say you're in the outfield and you're trying to throw it into someone like at second base, then that will probably have more of an arc to it and have more of a velocity because it'll go up and then down again in an upward direction. So that's all we're going to do in terms of notes today. I'll fill in that zero there at the end to complete the paper. And then tomorrow in class, we're going to take this velocity formula and apply it to some real world scenarios. And because it has the velocity B term, we will be using the quadratic formula all throughout class tomorrow. So these are longer problems when a B term is present. Have a great rest of your night, guys, and I will see you tomorrow.